Okay. I think I'm going to try to wrap my head around. Before we work on placement, I want to make sure we can pick up stones from a stack higher than 5. So right now we're able to pick up a 4-stone stack. We're able to drop as many as we want and lock it in, and then instead of working on placement just yet, I want to make sure we can move a stack that is having more than 5 occupants. So the issues in that is that right now we default to picking up all the stones, which means they keep the same exact stack order. And their stack order means that we're rendering them at the correct shrinkage. But, and I guess, God. Okay, so yeah, if we pick up more than 5, we should keep their stack order too. And then we drop them, reassign their same stack order. That's fine. It's just that when we get to placing them, we need to reassign the stack order according to what's in that space. So maybe it's not as bad as I'm thinking, at least for this part, which is to change everything, take out all the objects here. Where is it? Here. So if we click, if we're in a move type move, and we haven't locked in our movement origin yet, I just ripped my shorts, lifting my leg. Oh my god, yeah, I just ripped my shorts. Here, listen to this. That's my shorts. Goodbye, shorts. Well, it was nice while it lasted. Let's take a look at what we're currently doing. So we have this condition where we have to, or where we only do this if our occupants are 5 or less. Now, why do we exactly do that? Well, for every one of our occupants, we give our mouse stone an occupant for every occupant, and then we assign each member's stone color, stone type, and stack order into our mouse members, and then we nullify our movement grid. So instead of saying, yeah, the problem is this will nullify the first 5 members in our movement origin space, but what we want to happen is nullify the top 5 members. So maybe we can do a decrementing for loop like we did in a previous episode, and if the object isn't nil, yeah, because like instead of locking this in at, we're locking in this for loop for however many occupants are in the grid. Now, we could do 2 things. We can say, hey, if it's a legal move and our grid is this, and we're not moving origin locked yet, do what we've been doing, which is working at the moment. We could add another condition in the else if right here, and say, else if occupants greater than 5, then we're going to count down from our 10th member. And if we're not, we're going to redo that. How would we only do 5? But only do 5 from the topmost. We can take the amount of occupants. Let's say, for example, if there's 6 occupants, we would need to pick up the top 5. So we would say, we know we need to pick up 5. So we start. How do we do that? We would know we need 5, and if we're 6, then we're starting on the 2nd member. Okay, so yeah, we can do something like that. Or we could say, oops. So, if our grid at our mouse position, once we click, if what we click on is a legal move, and our occupants in that grid we clicked on is actually greater than 5, meaning 6 or above. Mouse Y grid, mouse X grid. If their occupants is greater than 5, meaning 6 or above, and we're not movement origin locked yet, then we need to do our logic, which we still need to do the same thing, which is lock in the movement origin row and column based on where our mouse was clicked. Then we need to move the top 5 occupants into the mouse stones. Now, we need to keep the stack order because I don't want to necessarily do any dynamic rendering for once you pick up things. To put this in perspective, if we pick up from a grid space with 5 occupants, our topmost stone will be 5 stacked shrink. Gosh, it's just hard to explain. Basically, once I click to take, if there's 10 stones in a grid, I click to take the top 5. I want just the 5 to come off and stay on our mouse. So we should keep the stack order. And then keep the stack order for when we dump them. And or pick them back up again. Because I don't want any dynamic resizing of that. I think it makes most sense to keep it stationary. So we know we need to do, if the occupants is greater than 5, then we know we need to assign 5 members into our mouse stone members. So our for loop can be just 5, but we start off at I will get assigned to be 1 more than the amount of occupants. Is that right? No. 1, well, let's see. Will leave us a note saying move top 5 members into mouse stones. So we know the for loop needs to be 5, but we need to start the I at a certain index so that we only grab, we need to grab, for example, if there's 6 objects, then the first index would be 2 because that's the first of the top 5. Now if it's 7, it would be 3. If it's 8, it would be 4. If it's 9, it'd be 5. So the occupants minus 5. No, minus 4. Yeah, occupants minus 4. So if we say we take our current stone we clicked on, grid we clicked on, mouse Y grid, mouse X grid, that stone we clicked on, its occupants minus 4 will give us the index of the lowest of the 5 stones. So 5 stones from the top of our 5 stones from the top as an index, but we need to limit it to 5. So that would mean it would be the occupants plus 1. Is that right? For the other, let's do this where, okay, if there's 6 occupants, we pick it up. The I would initiate to 6 minus 4, which is 2. So meaning 2, our second index would be the bottom member of our mouse stones, which is correct. And then we would do it 5 times. And this would be, since our occupants was 6, 6 plus 1, which is 7, but we're going from 2 to 7, so 2, 3, 4, 5, 6, 7, that's 6. So maybe it's just for the occupants. Let me see. Let's imagine this with 10 occupants. 10 minus 4 would be 6. So the 6th index, yeah, it's not occupants. 6th index. No. 6th. 6 to 10, 6, 7, 8, 9, 10. That's 5, I think. So that might be right. Because we're trying to do this for loop 5 times. I think that might be it. And we need to do it in that weird way because we need I to be equal to the bottom stone of the bottom, the 5th stone from the top, basically. Yeah, this 5th stone from the top. And we need access to that because that's the stone we need to start incrementing. And then that number will get bigger every loop until we get to the topmost stone. Yeah, I think that's right. So now that we've got the for loop, we need to do this same thing where we're like, we increment our mouse stone occupants. We copy over our member at that ith position. We copy over that field stone color into our mouse stones at that member, at the member I. So the bottom stone, 5 stones from the top, will get that stone color. And then we need the same with the stone type and the stack order. We're keeping the same stack order for render purposes. And then we need to nullify all the stones that are in the grid we just clicked on once we've copied over into our mouse stone objects or members. And then the amount of stones that we picked up becomes how many occupants are in our mouse stones, which would just be 5. We need to actually not do that because we didn't pick up every stone. We did. No movement locked becomes false. Our movement origin locked becomes true. Our move locked highlight becomes true to highlight that dark green spot. We lock in where our move locked row and column is. We turn off highlighting for that space we clicked on, and then we assign, yeah, we don't need that assignment here of our mouse grid occupants, but we need to decrement our mouse stone or our grid occupants for every, yeah, we would need to subtract 5. So we would say mouse stone occupants gets whatever its current occupants are minus 5. So we fix that, well, hoping. And then yeah, it's still, the stone is still occupied, the grid is still occupied, so that might be it. In order to test it, we need to give ourselves more. So if we've got white, black, let's make this a lay stone. We need to do members or occupants equals 10. So we're doing a 10. We're doing a max stack here to see what it would look like. So for our 5th would be 5th. And it would be a white lay stone with the white stack control. Stack order is 5. Then we would need a 6th. We don't need to assign this stack control every single time. I'm just doing it because it's consistent, I guess, for this test. This needs to be black. Lay stone, that's fine. Black. There's our 6th. We need our 7th. There's our 7th. Alternate colors so we can see what we're looking at. Then we need a black. And it's our 8th. Stack order of 8. Then we need a 9th, which is white. Nine. Stack order of 9, and then our last 10th black stone member, which is at members 10. There was 1 indexed, so 10 is actually the 10th item. Stack order of 10. And then the moment of truth. That looks sick. So look, that's the highest stack you can get. A stack of 10. So I'm hoping when I click this, we'll take the top 5 occupants. Oh my god. Did that work? Yeah, we've got 5 occupants. See, and we kept the size. Now let's see if we can drop them. Nope. 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 Let's take a look at our drop logic, because right now we're doing it based on our bottom stone index is not getting assigned to the right number. So I think actually if we do that, so our bottom stone index starts at 1. And then if you take a look at once we press down in our click detection and a move type move, we press down, we increment our bottom stone index. See, this is wrong too. This is wrong. Shoot. Because our bottom stone index could be higher than 1 if we pick up. Our bottom stone index needs to be assigned to our stack order of our bottom stone. Shoot. Bottom stone index logic is what's kind of screwing us here, because it's locked in. If we assign our bottom stone index to the stack order of the first stone that's picked up, then we need to just change this loop. Yeah, we need to only increment our bottom stone index if down is pressed. Oh, how do I do this? How must I teach these kids? Yeah, this is the problem here, the bottom stone index. Now we need the bottom stone index because we need to decide which mouse stone member. Oh, you know what? No, this is... Our mouse stone member at index 1 would have a different stack order, but it should still be the bottom stone index of 1, because we can only have 5 members. Yeah, our mouse stone occupants is still only 5 once we pick up. So our bottom stone index would be 1 still. Yeah, we have 5 occupants, bottom stone index is 1. So how come pressing down doesn't move our mouse stone 1? It doesn't nullify that. How come? Oh, wait, no. I'm actually confused why this isn't working, because this actually kind of... Our mouse stones would be the same. Let's see, down is pressed. Our mouse stone... So if our mouse stone has more than 1 occupant, then we would... Oh god. Yeah, we would take the bottom stone index, which is 1. I actually don't know why it's not working. We become occupied. We nullify the members. Yeah. Does our bottom stone index increment correctly? Yes, it does. And our members does too. Okay. So lowest stack order is staying stationary. Where are we using this lowest stack order? Lowest milestone stack order. Where are we using this? Oh my god. Okay. Okay, so this should be the first one. This is what's getting... hold on, let me try. I'm gonna copy this. I'm going to comment this out, and I'm gonna turn on instead just 3. The first 3 stones, and I'm going to look at that lowest stack order and see how it functions. Lowest stack order is 1, 2, 3. Yeah. So lowest stack order is kind of tethered to bottom stone index. So why don't we just use bottom stone index for lowest stack order? That's the same. Is that not the same thing? Lowest milestone stack order. Where do we don't even initialize this. Okay. We assign it. We start at 10. We count downwards. And if it is not nil, if the member's stack order is not nil, meaning our stone exists, if our stone exists, then our lowest stack order gets that existing stone's stack order. What if I just change this? Let me actually, lowest stone stack order. And we're taking our stack, copy movement origin stone into milestone. So we use that. Yeah, why don't we just use bottom stone index again? Oh, if we pick up stones. Shoot. Hold on. Let me see if we pick up stones, if it comes decoupled from our index. So bottom stone index and low stack order are 1, 1, 2 and 2, 3 and 3. No, it does look tethered to it. Okay, let's just try that. We're going to use our bottom stone index instead of lowest stack order and see if that fixes some of our problems. I'm very confused here, actually. We decrement our bottom stone index if we pick up a stone. If we pick up a stone, no. Yeah. If we pick up a stone instead of drop a stone, we're we subtracting? We're subtracting a stone from our bottom stone index. Then we're copying our member there, oh my God, into we're copying the topmost stone. We're copying the topmost stone into one index below. Yeah, one index below our mouse stones. That makes sense. But then we're I guess let's just switch it here and see. Bottom stone index gets incremented. I don't like that we decrement it, then we increment it. That doesn't make any sense to me. What? What? Okay. See, it would make sense to me that we increase the bottom stone index. We subtract 1. Why don't we instead... No. Gosh, I don't know. Let me just see if that's busted or not. Let me make sure our lowest MS stack order. Okay. Let's see if our pickup is screwed up on our 3. Right here. Oh, see, look, it doesn't render correctly anymore. So our bottom stone index is not decrementing appropriately. Really. Bottom stone index is 1, 2. See, if we press up, we should go back to 1, which it does not. Okay, let's undo that. Okay. Oh. Well. Let's see. Okay, well. I'm a little confused why we can't just use the same number. But it broke when I tried to change it, so let's go back. We've got that working. It works for less than 5 stones. So I guess let's see the difference when we turn on our 10 stack. We turn on our 10 stack. And then we see what our lowest stack order would be. Our lowest stack order is 6. It should be 5. No. It should be 1. Let me just assign it to 1, because look, if it actually doesn't increase. Shoot. Is our down logic only applying if we're less than 5 occupants? Down. No. Our less than 5 is only here. And that ends here. So why is our milestone occupants greater than 1? How come? Ooh, it's got to do with this. God dang it, God dang it. Yeah, our bottom stone index, let's just set this to 1. Is our bottom stone index being set where's our loop that we do that? I guess we were only doing that with not the bottom stone index, but the, what was the other one? Right here, our lowest mouse stack order. So our lowest mouse stack order upon a 10 stack click is the one that is messed up. So our lowest stack order is 6 when it should be 1. And that should allow us to drop the proper ones. So instead of populating this here, we're gonna put this, we're gonna do this 2 different ways. We're gonna put it once when we click on an occupants less than 6 right here. We're gonna do it right here in this case, and that gives us the proper stack order. Actually, how come we can't just say it gets 1? It should always be 1. Okay, before I move that into there, I'm going to turn that off. And I'm just going to assign it to be equal to 1 upon a less than 6 occupant click and a more than 6 occupant click. So I guess if it's clicked an illegal move right here, we're going to assign it just to 1. Lowest stack order gets 1. And then we're going to do it here in the else if for the 10 stack. So now instead of 6, it should be 1, and then we'll see if that allows us to drop stones. Nope. We fail at 399, which is lowest stack order gets we need to assign it to 1. Let's try it again. Okay. Huh. It doesn't increment. Okay. It doesn't increment because we need to get it, instead of assigning it to 1 upon a click, it's just overriding every time we do it. So we need to set it to itself plus 1. And we'll initialize it as 0, which we aren't even initializing it. So we need to increment it when we... Actually, yeah. This is wrong still. Lowest stack order. So if a mouse is clicked... Well, let's just see if we put it... We're not incrementing it, but we need to put it here. Nope. So we need to increment it in either of these cases by itself. Well, we'll start it as 0 and then we'll give it 1. So it'll become 1 once we're clicked, but then once we drop, we need to increment it, and once we pick up, we need to decrement it. So wherever we do that for our down press here, we need to do this. We need to increment it just like we increment this. I don't get why we can't use the same variable, because it's kind of locked. I don't get it, but let's just see if it works, and then we can see if we can fix it. So we increment it, and then we need to and occupants is smaller than stone picked up. Yeah, we should do something similar here. But let's just increment it. Oh, here. We need to, what, decrement it here? Just like we decrement, no? Oh, we decrement to here, and we decrement this here. So what if we do this here? We might want to change this back to bottom stone index, but it should be the same number. So let's just see. Come on, man. It's higher. It's one higher. Why is it lowest stack order is 1? Where are we assigning it to be 1? Yeah, we need this. Okay. All right. Moment of truth. Moment of truth. Come on. It's something different. We need to see why it's not able to pick up or drop when we press down. Let me see if our 3 stack is working appropriately. No, it's not. Stack order 1, 2, up doesn't fix it. So how come pressing up crashes? Let's try this line here instead. Come on, 3 stack. Okay. That's working now. Now let's try our 10 stack. Come on, man. It doesn't crash, but it's not working. How come we're not nullifying the mouse stone at members 1 upon pressing up. Because we can't even... So pressing down, when our mouse stone occupants is greater than 1, we'll play that sound and it'll nullify the members at bottom stone index. But it's because our bottom stone index is 1 and our members 1 is actually not being rendered. So we need to okay. Yeah, it's because instead of bottom stone index, yeah, well, okay, yeah, okay. So what's happening is that even though we only have 5 occupants, all of our first 5 members in our mouse stone occupants, when we pick up from a 10 stack, all of those are nil. And it's only till we get to the 6th stone that it's nil. So if I hard code this in at 6, then pressing down should nullify our bottom stack, our bottom stone in our stack. So that black stone should disappear when I press down, and it does. So that's what's wrong. Because our bottom stone index needs to be shifted. Okay. Yeah, because our bottom stone index isn't 1, it's actually 6. If we pick up more than 5, our bottom stone index is actually 6. And then this is incorrect because we are incrementing our bottom stone index if we're pressing down and it's smaller than the stones picked up, which we need to just fix that. Because that only works if you pick up less than 5. If you pick up more than 5, like stones picked up should be updated by, actually, yeah, we can just, where do we update stones picked up? Right here. And this is upon a -6. No, greater than 5. Okay, so if it's greater than 5, we get this plus 5. And then it might work, maybe. I don't know. No! Our bottom stone index needs to be updated by that number as well. So, where we did the, right here, our bottom stone index needs to get our stones picked up. No. Yeah. No. Well, if we pick up 5, yeah. Stones picked up. Yeah, we need something else. Shit. We need something else. You can't, it's not good to use the same variables for more than one thing, because if it gets decoupled, you're just screwed. So it's like we need another I don't know. It's almost there. It's that we need to the amount of code I'm looking at right now. It's just ridiculous. Okay, so no, I think I was onto something here with this lowest milestone stack order because it should be, yeah. Nope. That's, oh! Okay, yeah, that's jacked, but... God, I just need to rehaul a lot of things. I need to decouple the bottom stone index with the lowest milestone stack order, I think. We need to rename some things. We need it to be more specific because lowest milestone stack order should actually be... Actually, that's kind of right, but we need to rename our stones picked up. Oi, oi, oi. Okay. I mean, I think I'm wrapping my head around the problem. It's just hard. Yeah, we're gonna have to redo some stuff. We need to decouple it so that we're only doing like stones pickup needs to be renamed like drop limit or something like that, so we only use it for determining how many stones you can pick up or drop. So it's like a variable specifically, even though it was initially equal to the amount of stones we picked up. Once we pick up a stack higher than 5, it no longer equivalates to doing what we needed to do because the stack order changes for the bottommost stone. So we needed to kind of decouple that so that no matter how many stones we pick up, we can only drop 5 and we can only pick up 4, or we can only drop 4 and we can only pick up 4. So we need like a totally separate thing, and drop 4 at the most. Yeah, that's tough. But if we decouple that, then we can rename our lowest mouse stack order and our, there's another variable here, bottom stone index. Because right now bottom stone index is only doing the correct logic if the bottom stone index matches the bottom stone's stack order. So we need to either come up with another variable that we use if we pick up more than 5, which is maybe like the easy way to do it. Have like a less than 5 bottom stone index and then a more than 5 bottom stone index, because if it's more than 5, we know it needs to start at 6. That way, when we press down and up, it's not doing it incorrectly, because I think, yeah, we just need to assign it properly if it's picked up on a more than 5 or less than 5. And if you look here, our bottom stone stack index doesn't get assigned because it's still just 1. But then if we pick up more than 5, our bottom stone stack index, actually, we're not even doing that. Because we know bottom stone index needs to be 6 if we pick up from a stack higher than 5. Actually, no, that's not right. But in this case, when we pick up 10 stones, it is. Yeah, and then see, so that's the reason why we need, we shouldn't be able to pick up that many stones. It should be limited to 5, but changing what we just changed here, which is assigning this bottom stack stone index, we need to change this to be appropriate depending on occupants, which we can just actually do right now, where if our occupants are greater than 5, then if it's 10, it needs to be 6, so it needs to be occupants minus 4. So if we say the occupants minus 4, then it should still work for dropping the 10 stack. Yep, and then we see, so we need to limit it there. But then if we press enter, actually, that's weird. Our enter isn't really working anymore, so we'll have to fix that. Okay, well. Okay, so we might not need to rehaul everything, but we need to at least rehaul the allowing us to drop, because right now mass stone occupants, we can drop a stone as long as we have more than one stone in our mouse, which isn't just the case. No, yeah. And then we can only hit up if our, we can only pick up a stone if the amount of stones we've dropped is, so maybe we add a stones dropped that let's try that. So look, we say stones dropped is 0. Now if we press down in a legal move, we need to stones dropped gets incremented by 1. And then if we pick up a stone, our stones dropped gets higher by 1. No, lower by 1. Yeah. So we pick up a stone. And then we only are able to pick up a stone if our mouse stone occupants we can only pick up a stone if our stones dropped is less than 5. So we cannot pick up a stone if we've dropped 5. So now that should hopefully fix us from dropping infinite stones upon a 10 stack pickup. Or picking up. Nope. We can only pick up a stone if stones dropped less than 5. Down. Yeah, that's wrong. I don't know exactly how to fix that just yet, but we'll work on that. It makes sense that that wouldn't have worked, but I don't know how to fix it. So we'll just leave it out for now. We'll leave us a note saying limit stones you can pick up. Oh yeah, we need stones picked up. Actually, we have that stone. So are we using stones picked up anywhere? Okay. See, we need a different stones picked up. So that's like stones picked up in our hand for our mouse stone object, but we need stones literally picked up. Stones literally picked up from our. I don't know how to limit it, but limit stones you can pick up. Yeah, that needs some nuance to it. So it's like, I don't know how to do it, but I know we need to do it, so Jesus. Okay, well, we got a half fix. At least we can pick up a 10 stack, and we're wrapping our head around how to limit it properly, but then once we can pick up a 10 stack and we get our first movement locked in with our enter correctly to render the legal move highlights, then we can worry about placement. And then we can worry about second, third, and fourth moves. And then at that point, we're basically done with any move type you can do in this game. Then we can worry about win state, undo states, or undo functionality, and then scorekeeping, and then we're doing okay. Let's check our git diff real quick. We initialize our stack order this time. Lowest mouse stone stack order. We're doing a 10 stack and a 3 stack we can toggle. Geez, yeah. We changed some stuff. Yeah, we changed. Basically, we added all of the picking up more than 5 stone occupant and what that entails. Still busted though, but not so bad. We can add everything to the staging area with a commit message saying added picking up more than 5 occupant stack. Still busted on picking up stones. Git push it. Okay, I'll see you guys tomorrow, and we'll do hopefully a little more finessing of this, and then we can move on to the actual placement of the stones once you've locked in how many stones you want to drop and or move. So we're getting up there to finally move a stack. Finally. And then the tricky thing there is then we have to actually change our stack order to the new stack order that's in the empty space, because we need the dynamic rendering to be according to its stack order. So we'll need to do that. But yeah, I'll catch you guys tomorrow.